Dear students, welcome to today's class. In the last few classes, I have explained about the periodic nature of the function and periodicity of the function. In the last class also, I have explained the periods of some different functions. Okay, so in this class also, I am going to explain the period, how to find out the periods of different types of functions. So I have selected for your understanding, so different variety number of problems I have taken. Okay, so let us start our class. Now in the first problem, it is given that find the period of cos x plus cos of sin x. So what is the period of the function definition? If f of x plus p is equal to f of x, here p is the least positive real number. Least positive real number you have to take. So here if you understand, in place of cos x, in place of x, what value you have to substitute so that the function will remain same. Then what we will substitute here? See here, f of x is equal to cos x plus cos of sin x. So here f of pi by 2 plus x, substitute here. Wherever x is there, substitute pi by 2 plus x. So this is equal to cos, this is a pi by 2 plus x. This is cos of sin pi by 2 plus x. So this is cos 90 plus theta. Cos 90 plus theta is minus sin theta, but it is a cos function. In cos function, cos of minus is same. So that is equal to cos of sin x. This is a cos of sin 90 plus theta, cos theta. So this is cos x. That means for pi by 2 only, for pi by 2 only you are getting a same function. So actually speaking, not only pi by 2, for pi also you will get the same answer. For if you substitute pi, the value will be same. But out of pi and pi by, which is the least one? Pi by 2. So therefore, the period of this function is pi by 2. Understand this? Right. I hope that you understand this solution. Now coming to the second bit. So whenever this type of functions are given, two functions are given. Okay. So what you have to do is find the periods of each function separately and take their LCM. Okay. Now what is the function of this sine of something? First sine function period is 2 pi upon 2 pi upon what is the coefficient of x? What is the coefficient of x? Pi by n factorial, pi upon n factorial. That means pi will get cancelled, 2n factorial. Okay, now coming to second one. What is the cos x function definition? Cos 2 pi. What is the x coefficient? Pi by n plus 1 factorial. That means pi by n plus 1 factorial. Pi will get cancelled. So this is a 2 times n plus 1 factorial. Okay, now. So from these two, what is the LCM of 2n factorial and 2 times n plus 1 factorial? The least common multiple is, whichever is the highest, that will come 2 times n plus 1 factorial. So that is the period of the given function f of x. Okay, now. So I hope that you understand these two solutions. Let us go for some more problems. Welcome to this second problem. Here there are two functions are given. For first function the period is t1. For the second function the period is t2. He is asking the relation between t1 and t2. Okay, we will find out the period of the first function and the second function separately. After knowing the values of t1 and t2, we will get a conclusion. So what is the first function? What is the given first function is this. So this is equal to y is equal to e 3 times x minus step x. Okay, now e to the power of 3 times x minus step x. So if you observe here, this is a 3 times flower bracket x. That means a fractional part function. X minus step x is called fractional part function. So this is here only fractions of x. The period is equal to 1. For fractional part function, period is equal to 1. Therefore, t1 value is equal to 1. t1 value is equal to 1. But coming to second one is e power 3x minus step of 3x. Here 3 times x minus step of x, but here 3x minus step of x. That means e power fractional part 3x. This is called, for see here, if it is x minus step of x, we will write down fractional part x. That is the definition of fractional part function. Here 3x minus step of x, 3x minus step of x. So this is fractional part of 3x. Okay. Then what is the period of this function? Period of this function is, for x, fractional part function x, for x is equal to how much? 1. But what is the x coefficient here? X coefficient inside the fractional part, 3. That's why 3. 1 by 3 is the period of the second function. So you may get doubts. Sir, here we are getting 3, no, but it is 3 times step of x. 3 times x step of x. This 3 cannot be the coefficient of x. Here, sir, 3 times the fractional part of x. Here 3 cannot be the coefficient of x. Here fractional part of 3x. Fractional part of 3x. Therefore, here the coefficient of x is 3. That's why we have to write down 1 by 3. Already we have explained one concept. That's why. So this is therefore T2 is equal to 1 by 3. So then what can be the conclusion we will get? So therefore T2 is equal to, in place of 1, can I write down T1? So that is equal to T1 by 3. Therefore T1 is equal to 3T2. T1 is equal to 3T2. That is the relation between T1 and T2. So I hope that you catch this point. So this and this. For this, the period is 1. For this, the period is 1 by 3. Why? X coefficient is 3. Okay, na? I hope that you understand this solution. Let us go for next problems. Friends, here one problem is given. So this is the period of tan theta times 1 plus secant 2 theta plus 1 plus secant 4 theta into 1 plus secant 8 theta value is how. So if you want to find out the period of such type of functions, you should know some basic fundamental results in trigonometry. So what is the value of this tan theta 1 plus? So don't do that like so. The period of tan theta is 2 pi. For this 2 pi, the tan of tan theta is pi. For secant 2 theta is 2 pi by 2 pi. So pi by 4. This is a pi by 8. Don't take LCM. For that is for plus or minus. But it is a product of the functions. There is no plus and minus between these two these functions. Okay, na? Right. So for that, you have to do, so you have to make it into 1. So for this, we have a very important result. The result is this. So this is tan theta into 1 plus secant 2 theta into 1 plus secant 2 square theta into 1 plus secant 2 cube theta into so on 1 plus secant 2 power n theta is equal to tan into 2 power n theta. That is the formula. So once again I am telling, here first should be starts with tan, again secant. Secant 2 theta, secant 2 square theta, secant 2 cube theta, so on secant 2 power n theta. Then you will get tan of 2 power n theta. That means last thing, whatever may be that, you will get that here. 2 power n theta, 2 power n theta. Now coming to your problem. So this is also how much? Tan of, the last value is how much? 2 power. Here also it will come same. Here also it will come 8 theta. Tan of 8 theta is your answer. Understand this? So this is your tan of 8 theta. Now what is the period of this tan of 8 theta? For tan theta it is pi. 8 theta means by 8. Coefficient of theta is 8. So therefore the period of the given function is pi upon 8. Pi upon 8. Okay. The only thing is that you have to remember this result. This result you have to write. Otherwise, you cannot do this problem. That means you have to simplify this problem. Okay. Then you will get tan 8 theta. If you know the result, the problem will be very, very easy. Okay. Na? I hope that you understand this solution. Let us go for next problem. welcome to the next problem. If f of x satisfies the relation, there is a relation it is given, that is f of x plus f of x plus 4 is equal to f of x plus 2 plus f of x plus 6, then the period of f of x. So, if any this type of functional equations are given, then how to do this problem? So, here you have to think in a logical way. So, whatever may be that, we have to get f of x plus p is equal to f of x. This p is the period. So, you have to convert that equation, you have to simplify that equation such that it should come f of x plus p is equal to f of x. If it comes f of x plus 2 is equal to f of x, 2 is the period. If it comes f of x plus 8 is equal to f of x, 8 will be the period. Whatever may be the value will come in place of p, that will is your period. Then how to proceed this problem? How to proceed problem means here x is there, x plus 2 is there. X plus 4 is there, here x plus 6 is there. So, can I replace x with x plus 2? Here x is there, x plus 2 is there. That means if I put in place of x, again it will come x plus 2. So, here it will be x plus 6, here x plus 6 is there. Here x plus 2, here x plus 4 will come, again it will come. Let us see that what happens. So, I call it as this first equation. Now, wherever x is there, substitute x plus 2. So, this is f of x plus 2. So, this is f of x plus 2 plus 4, x plus 6 is equal to f of x plus 2 plus 2, x plus 4 plus this is f of x plus 2 plus 6, this is x plus 8, call it as second equation. Now, see here, then how to proceed here? So, here f of x plus 2 is there, f of x plus 2 is there, here f of x plus 6 is there, f of x plus 6 is there. See here right hand side quantity, here right hand side quantity, f of x plus 2 plus f of x plus 6. Here right hand side quantity, f of x plus 2 plus f of x plus 6. These two quantities are equal. Therefore, can I equate these two quantities? Sure, I can equate. That is f of x plus f of x plus 4 is equal to f of x plus 4 plus f of x plus 8. Clearly, f of x plus 4, f of x plus 4 will get cancelled. Therefore, what you got? So, f of x plus 8 is equal to f of x. F of x plus 8 is equal to f of x. That means, f of x plus p is equal to f of x. That means, in place of p, what is here? 8 is there. Therefore, this is your period. What is the period of that given function? 8 is the period of the given function. Okay, na? So, very easy problem. The only thing is, in place of x, substitute x plus 2. Sir, how we will get that type of idea, sir? Just how you say that means this will come by practice. By practice. If you do this type of problems, number of problems, if you practice this type of problems, automatically the idea will come. Automatically it will come. Then you can put x in play, x plus 2 in place of x. Automatically it will come. Okay, na? So, I hope that you understand this solution. Let us go for next problem. Welcome to next problem. Here one question is given, which of the following are non-periodic functions? Here 4 types of functions are given. 1, 2, 3, 4. 4 functions are given. Out of these 4 functions, which is periodic? Right, one by one check. See the first function f of x is equal to, this is clearly a periodic function. Why? Because it is a fractional part function. It is a fractional part function whose period is 1. Whose period is 1, right. And one more thing is cot of x plus 7. Cot of x plus 7. Cot of x plus 7. It is also a periodic function. Clearly, whose period is pi. Whose period is pi. Tan x and cot x, the periods are pi. Coming to the third one, it is also a periodic function, clearly, whose period is pi. Sir, how can you say, sir? Right. In place of x, substitute pi plus x. Here also substitute pi plus x. Here also substitute pi plus x. Here also substitute pi plus x. Let us see what happens. Sin of pi plus x. Sin of pi plus x means minus sin x, but square is there. That's why plus sin square x. Cos of pi plus x, that is minus cos x. Why? Because it is in the third quadrant, pi plus x. Therefore, third quadrant cos is negative. But since square is there, the negatives will go. That means again it will become cos square only. Of course, tan of pi plus x is cot theta. Cot of pi plus x is cot x only. Why? Because in third quadrant, cot and tan both are positive. Therefore, the least positive real number is pi. Okay. So, if you substitute pi by 2, if you substitute pi by 2, what happens? You see here. Now, if you substitute pi by 2, maybe I think something less than pi by 2 plus x cos of, no, pi by 2 plus you won't get. Why? Because if you put pi by 2 plus x, so this will become minus cot x, minus tan x. It won't come. Therefore, only pi is the right answer. Okay. So, this is also a periodic function with the period pi. Pi by 2, it cannot be the period of that function. Pi only the period of that function. Coming to fourth one. Is it the periodic function? Clearly, sin x is a periodic function with the period 2 pi, but f of x is equal to x is not periodic function. Remember always, is not periodic function. F of x is equal to x is not periodic function. Why? Why? Because what is the definition here? F of x plus p is equal to f of x, where p is the least positive integer. Least positive integer. X p cannot be equal to 0. He is saying that in the definition, p is the least positive integer. Least positive integer means what? Not positive integer, positive real number, not real number. Positive real number, sorry, not integer, positive real number. He is not saying 0. That means you cannot put 0 here. That means x plus 1. So, can it be f of x? If you substitute here f of x plus 1 is equal to, can it be x? No. The only thing what you have to substitute is, in place of x, you have to substitute x plus 0, then it will become x. Okay, now understand this, right? So, that's why always remember that f of x is equal to x is not a periodic function. Therefore, it is not a periodic function. Its period is not defined, even though its period is not defined. Its period is not defined. Okay, now, right? That's why on the whole, this is not a periodic function. So, it is a non-periodic plus periodic. On the whole, it is non-periodic function. Okay. So, from this problem, what you have to catch is, the only thing, f of x is equal to x is not a periodic function. It is not a periodic function. Okay, right? X square is also not a periodic function. Already I told that the x should be a linear, x power 1, 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 linear. It should be linear. If it is x square also, it is not a periodic function. Okay, now, right? I hope that you understand this solution. Let us go for next problem. We have to find out the period of one of the function it is given. So, f of x is equal to step of x plus step of 2x plus step of 3x, that means greatest integer function of 3x, so on, step of nx minus n of n plus 1 by 2 of x, where n belongs to natural number. Okay, now, so this type of problems will be asked in definitely JEE mains examination. So, very important for this is JEE mains examinations. Definitely this type of problems will be given. So, whenever such type of functions is given, so you have to remember the definition of the definition of the fractional part function. What is the fractional part function? X minus step of x. X minus step of x. Okay. Now, if you observe here, in place of n into, you are observing here, you are seeing one formula, n into n plus 1 by 2. N into n plus 1 upon 2. It is a sum of the first n natural numbers. So, let us open that first of all. So, this is a f of x is equal to step x plus step of 2x plus so on step of nx minus n into n plus 1 by 2 means what? Sum of the first n natural number 1 plus 2 plus so on plus n into x. Okay na? So this is equal to step x, step 2x plus so on step nx minus you multiply inside x plus 2x plus 3x plus so on nx. Okay na? So now write it as, now you combine these two, step x and minus x. What happens? So step x minus x, one bracket, plus step of 2x minus 2x, one bracket, plus step of 3x minus 3x, one bracket, so on, step of nx minus nx. Okay. So this is nothing but, so step of x is, fractional part of x is equal to x minus step of x. So here reverse is there. So therefore minus of, so here also minus of 2x. This is minus of 3x, fractional part of x. So on, minus of nx. Okay na? So take minus common outside. So this is a fractional part of x plus fractional part of 2x plus fractional part of 3x plus so on fractional part of nx. Okay, right. Therefore, from this what can you say? What is the period of f of fractional part of x? 1. What is the period of fractional part of 2x? 1 by 2. What is the period of fractional part of 3x? 1 by 3. So on. What is the period of fractional part of nx? 1 by n. For this, what you have to take? LCM, least common multiple you have to take. Least common multiple. So 1, 1 by 2, 1 by 3, so on, 1 by n. What is the least common multiple? 1 is the common multiple. So therefore, the period of the given problem is 1. The only thing is, for this problem to be solved, first idea what you have to get is n times n plus 1 by 2. That is sum of first n natural numbers, that is 1 plus 2 plus 3 plus so on n. If you get that idea, the solution is very, very easy. Okay na? I hope that you understand this solution. Let us go for next problem. Welcome to this problem. The period of the function f of x is equal to 3 power sine square pi x plus x minus step of x plus sine power 4 pi x. How to do this problem? So up to here no problem. Its period is equal to 1. Up to here no problem. Its period is equal to y. Why? Because that is a fractional part function. No problem. Now coming to sine square pi x, sine to the power of 4 pi x. If you know those period, for these two periods also, you know, you can take the LCM. Okay. But what about sine square pi x period is equal to how much? Sine square pi x period. Yes, we know that 1 minus cos 2a is equal to 2 sine square a. One formula is there. In trigonometry, 1 minus cos 2a is equal to 2 sine square a. Okay, cos 2a is equal to 1 minus 2 sine square a. So it is also, therefore, sine square a is equal to 1 minus cos 2a by 2. So this is also sine square a. Sine square a. That means sine square a means what? I am taking this sine square pi x separately. This is a 1 minus cos 2a. That means 2 pi x upon 2. 1 minus cos 2 pi x by 2. So what is the period of this function? 1 minus cos 2 pi x by 1 minus cos 2 pi x by 2. So put it like that. Coming to this second period, this one, this is a sine to the power of 4 pi x. This is equal to sine square pi x whole square. Can I write it as sine square pi x whole square? Sine square pi x means 1 minus cos 2 pi x by 2 whole square. 1 minus cos 2 pi x by 2 whole square. So this is a minus b whole square. A square minus 2ab plus b square. B square means what? This is a cos square 2 pi x upon 2. a minus b whole square. Again a square minus 2ab plus that is a cos square. B square means cos square 2 pi x. Okay, now coming to now here the problem will arise. Again cos square 2 pi x is equal to how much? So this is equal to 1 minus 2 cos 2 pi x plus cos square x. Cos square x can be written as 1 plus cos 2a by 2. This is equal to cos square x. Okay. Cos square a is equal to 1 plus cos 2a by 2. So this is also, if it is a is there, 2a. Up to here we can write it as 1 plus cos, if a is there, 2a. This is a 4 pi x by 2 whole divided by 2. Okay, now, right. So we know that sin square pi, that means we avoided this sin square sin to the power of 4x. Sin square x is 1 minus cos 2 pi x by 2 I wrote. Sin to the power of 4 means sin square whole square. Sin square pi x means 1 minus cos 2 pi x by 2 again whole square. So this is, of course, you will get 4 here, 4, it is also 4. Okay, now, right, a square minus 2ab plus b square. Again you got cos square 2 pi x here. In place of cos square x, in place of cos square a, I can write on 1 plus cos 2a by 2. Here also 1 plus cos 2a, this 2 pi x means 4 pi x by 2. Okay, take the LCM and do the problem. LCM and do the problem. So here, so if you simplify this, here you will get 1 by 2 plus 3 by 8 and multiply whatever may be that. So here, what is the period of this cos 2 pi x? The period of this cos 2 pi x is for cos x 2 pi by 2 pi, comma. Cos 2 pi x period is cos x period 2 pi by again 2 pi. Cos 4 pi x, cos x period is 2 pi by 4 pi, again its period is 1. So LCM of this, okay. So thus are 1 by 2, 3 by 4, they are constant, leave it that constant. So we won't bother about the constant, and here denominator quantities we won't bother. So we will concentrate on the trigonometric functions in which all are cos square is there, cos square not there. So we will remove all those things, okay. Ultimately we got, so this is 2 pi cancel, 2 pi, 2 pi p also 1 by 2. So on the whole 1 comma 1 comma 1 by 2 comma 1. So what is the LCM? 1. What is the LCM? So therefore the period of this function is 1. Okay, now, right. I hope that you understand this solution. Let us go for next problem. Welcome to this problem. Here one summation function is there. Sigma r runs from 0 to n, f of x plus Ra is equal to 0, where a greater than 0. Then the period of the function f of x is. Okay. So if this type of sigma summation problems is given, first you open that summation. What happens? See here, from r runs from 0 to n. So here r is there. So wherever r is there, put r is equal to 0, 1, 2, 3, so on n. So what happens? You see. So there's the first term is f of x, r value is 1, f of x plus a, that is f of x plus 2a, this is f of x plus 3a, so on f of x plus na, that is equal to 0. Call it as equation number 1. So already told this function, this problem is a r runs from 0 to n. So if that means you can put 0 also here. So that is f of x also will come. So that is the equation 1. Okay. So how to do? You have whatever may be that you have to get like this, f of x plus p is equal to f of x. Therefore, whatever may be the value in p, that will be your period. Now what I will do now, wherever x is there, you can put x plus a. See here, x plus a, x plus, again x plus 2a will come. Here again x plus 3a will get. So if you subtract, the problem will be over. So now the new function is f of x plus a. This is wherever x is there, I am substituting x plus a. X plus 2a, this is f of x plus 3a plus so on. This is a f of x plus, in place of x substitute x plus a, that means x plus a means 1 plus n into a, u is equal to 0. That means here I added a, na plus a. That means you can take a common, n plus 1 a. Now what I will do is, see here, f of x plus a is there, here also f of x plus a. Here f of x plus 2a is there, here also f of x plus 2a. F of x plus 3a here also. So from this what can you say? If you subtract from 1 minus 2, first equation minus second equation, f of x plus a, f of x will get cancelled. So this f of x remains. All these will get cancelled. So here the previously what will be here? This is f of x plus na, n plus 1a. So this also will get cancelled. All will get cancelled. Ultimately, this minus, after subtraction will get minus. Minus f of x plus 1 plus a into n is equal to 0. So this is f of x plus 1 plus n into a is equal to f of x. Okay na? So by definition, so in place of p, what is there? 1 plus n a into a. So p is equal to how much? 1 plus n a into a. So this is the period of your function. The period of the given function. Okay, right. So very easy problem. This is the only thing is first expanding the function summation and getting the idea that in place of x put x plus a. Okay, automatically after subtraction, generally addition or subtraction will give the answer. After getting two equations, sometimes addition, sometimes subtraction. Okay na? I hope that you understand this solution. Dear students, I hope that you enjoyed today's class. So by seeing all these models, you also practice problem. So in the next class, I am going before you with the maximum and a minimum of a function. Whatever may be the function, maybe trigonometric function, whatever may be the function. What is the range of the function? That means what is the maximum value and a minimum value. Okay na? I hope that you enjoyed today's class. So let us see in the next class.